Hi everybody, so today we're going to be doing notes on section 1.7, which is all about absolute value inequalities. So the last time we did notes, it was also section 1.7 on absolute value equations. I am going to do a really quick review on that because I realized I left a couple of things out when I did the last set of notes on absolute value equations. So go ahead and take a minute, pause this screen so you can write this down, and then I will explain it. All right, so just a reminder, absolute value equations. The absolute value represents the distance the number is from 0 on a number line. So for example, when we see the absolute value of x, that's like saying if there is a little invisible -0 there, equal to some number, we'll call it k, that's saying that the distance from 0 on the number line is either k in the positive direction or negative k in the negative direction. So that's why when we solve absolute value equations, that's why we have two separate equations. Now this is the part that I realized I did not include in your last set of notes. I made it so that whatever came out of the absolute value, you make that the positive option and the negative option. That's one way to do it. You can also apply it to the answer. You can make the k value, whatever's on the other side of the equals, positive and negative. I forgot that part in your last set of notes on, what is today? 2 days ago, your notes from 2 days ago. So I want to make sure that's included. And I'm going to show you one example using that method. All right, so here is our first example. And I already wrote out my two equations. So I made it where the 4x is positive for one option and the 4x is negative for the other option. And now I'm going to go ahead and solve both of these. So if I want to solve for x, since it's already isolated over here, I'm just going to move everything over to the right. So I'm going to subtract 2x from both sides, and I get 12 equals 2x. Divide both sides by 2, we would get x equals 6. So I'm going to go ahead and just write it like that. I'm going to assume that you're able to go from that step to there. If you're not, then just let me know and I'll help you out. Same with this one. I'm going to subtract 2x from both sides. So then I end up with 12 equals negative 6x. Divide both sides by negative 6, and I get x equals negative 2. So those are my two answers that look like answers, but we still need to plug them back in and double check to see if they are in fact solutions. So that's what we're going to do now. So let's check. All right, so when I check x equals 6, I'm going to plug it back into the original equation. So I'm going to have the absolute value of 2 times 6 plus 12 equals 4 times 6. Simplify that. That checks out. Oops, let me scoot that down. That checks out. We're good to go. But we also need to check the second answer, which is x equals negative 2. So I'm going to plug that back in as well to the original. The absolute value of 8 is not equal to negative 8. This is false. But this one worked, which means our only answer is x equals 6. That is the only answer that works. So x equals negative 2 looked like it would be an answer, but when we plugged it back in, we found out that it is not actually an answer. All right, I'm going to go ahead and pause this video and write down your next section. I'm going to figure out how to pause the video. Whoops, not that. Oh my goodness, I'm so sorry. I'm not sure if I can cut this out of the presentation. Let's see. All right. All right, I'm back. So sorry about that. I have like 20 tabs open on my computer and I could not find the one that has Screencastify to pause the video. All right, so now getting into the new stuff, solving absolute value inequalities. There are two different kinds. You can go ahead and pause this and copy down this chart, but there are two different kinds, either less than, which is the less than and less than or equal to symbol, and greater, which is the greater than and greater than or equal to symbol. I like to remember it with these funny sounding words because that helps me remember if I'm setting up an and statement when I solve it, or if I'm setting up an or statement when I solve it. That's how I remember it in my head. And then my graphs of each, remember when it is greater than or less than, it'll be open circles. And then when we have that or equal to, it will be closed circles. All right, let's go ahead and do an example. So go ahead and pause and write down this example. First thing I want to ask myself, is this going to be greater or less than? It is a greater than symbol, which means this will be greater, which means I'm going to be writing an or statement with two separate things that I'm solving. All right, so when I write this out, I'm going to copy what's inside my absolute value, the 4x plus 5 greater than 13. I copy it exactly how it's written without the absolute value. Or, that's where the greater comes in. So, or, copy what's inside the absolute value. But now I'm going to flip the sign and make it negative. These are the two things that I'm solving now. All right, let's do the one on the left. Subtract 5 from both sides. Divide both sides by 2. All right, other one. Subtract 5 from both sides. Divide both sides by 4. All right, now I can simplify this. You can write that as a fraction or a decimal. All right, now you can either leave your answer written like this, or you can rewrite it all as one line. I'm going to do that just so it looks a little bit nicer. So my final answer is x is greater than 2, or x is less than negative 9 over 2, or you could write that as negative 4.5, whichever you prefer. And my example also asks us to graph it. So I'm going to draw my number line. Again, I'm not super picky with number lines. Please don't put all of the values on here. So negative 4.5 and 2. You don't need to label everything on this graph. All right. So I'm going to have an open circle at 2, and it's all the values bigger than that. So it's going to the right. I'm going to have an open circle at negative 4.5, and it's all the values less than that, going to the left. And also remember the cool little trick. When your variable is written first, your little arrow goes the same direction that your inequality is pointing. Fun little trick. All right, I figured out where my pause button is. That time for Screencastify. So here's our next example. You can go ahead and pause and write that down. First thing I want to look at is inequality. It is less than, which is less than. I'm doing an and statement, which means I'm going to rewrite exactly what's inside of my inequality. I'm going to write it as, 2x minus 1 less than or equal to 11. Rewrite it exactly as is, but now I'm going to add the option of negative 11 on the other side. And notice this inequality is still going the same direction. All right, now remember, for solving these compound inequalities, anything you do to the middle, you have to do to the left side and the right side. Keep it balanced. So I'm going to add 1 to the left, right, and middle. Now I'm going to divide everything by 2, left, right, and middle. Negative 5, x in the middle, 6 on the right. And we have our answer. Now I want to show you another way to do this. So if you were to write this as 2 separate statements instead, you could write it as exactly as is without the absolute value. So 2x minus 1 less than or equal to 11. And I'm going to write that out again, 2x minus 1. But now I'm going to flip the inequality and make it negative 11. And I'm going to show you how these answers compare. So add 1 to both sides. Divide both sides by 2. The one on the right, add 1 to both sides. Divide both sides by 2. These answers should look oddly similar to you. The only difference is this one is written as a compound inequality. This one you split up and wrote as 2 separate statements. But I'm going to show you on the graph. So when you graph this, again, please don't put every number on here. I'm just working with negative 5 and 6. Now both of these are closed circles. They are all or equal to. Now the cool thing about writing it like this, x is literally in between negative 5 and 6. Your graph is literally in between negative 5 and 6, and you're done. Now when you split it up into 2 separate statements, it gets a little trickier to do the actual graph. X is less than or equal to 6, so it's everything going this way to the left. And x is greater than or equal to 5. It's everything going to the right. You're looking at the overlap, which is that area, that section right there. So that's where it does get a little bit tricky when you separate it into 2 separate statements. I personally prefer to leave it all as 1 statement, and that is how I will always do it in the notes and on the homework. But if you prefer this method instead, that is fine. And I'm going to write a little note here of how we say this. X is between negative 5 and 6. Because when we look at it, x is literally written in between negative 5 and 6. All right, let's look at one more example. All right, here's our last example. Solve and graph, this guy here. But when we look at it, we have all sorts of stuff in the way. My absolute value is not by itself. So before I can do anything, I need to get the absolute value by itself. So I'm going to write a little note that says that. You must get the absolute value, I abbreviate that as ABS, the absolute value by itself first. Always, always, always. All right, so to do that, I'm just going to rewrite it over here. 2 times the absolute value of x minus 4 plus 3 less than 19. So I'm going to subtract 3 from both sides. Same way you would solve an equation that didn't have absolute value bars. That line isn't very nice. It kind of went like halfway through the line below it. I'm going to fix that. All right, so 2 times the absolute value of x minus 4 is less than 16. Now I need to divide both sides by 2. Sorry, that may be a little hard to read too. Let me write that 6 a little nicer, in case you're watching this without sound. All right, divide both sides by 2. Now I'm left with just x minus 4 less than 8. Now that my absolute value is by itself, I can look at my inequality and say this is less than. So I'm going to be writing one statement. All right, so when I write this, I'm going to have the x minus 4 less than 8. I'm going to rewrite it exactly as is, but then I put the negative option on the other side and put my inequality in. And my final step is to add 4 to the left, right, and middle. So I end up with negative 4x and 12. All right, and last but not least is to graph. And I'm just going to put negative 4 and 12. Less than, less than. Both of them are open circles. X is literally written in between negative 4 and 12. On my graph, it's literally what's in between negative 4 and 12. And that is my final answer. We are officially done with section 1.7. Have a good rest of your day.